I'm making this video to go over some soldering techniques we can use when we're using a low-cost soldering iron and low-cost supplies. The previous video I did went over soldering, and the video wasn't super great. It was kind of shot with my phone. So I'm going to try to do this one maybe with maybe have the board under a microscope while doing it. But the main thing is we're going to be going over soldering with one of these kits. And the other main thing to keep in mind is I haven't ever done this before. I've obviously used poor soldering irons in the past. But as I go through this video, this is kind of me using these irons for the first time. And what I'm going to try to show you is some techniques you can use when soldering with these low-cost irons. They're not as good as the fancy ones. And there's several reasons for that. The biggest reason they're not as good is the fancier soldering irons are capable of pouring a lot of power into the tip of the soldering iron when needed to maintain the temperature. So irons like these cheap ones, they sort of are they just generate heat. They just kind of have always constant output power. So if they touch anything that sucks heat energy out of the iron, it'll just cool the iron, and the iron has no dynamic way to respond to that. Expensive irons, not only do they usually have temperature feedback, but they usually also have, the really nice ones have very advanced controls in that they can't actually measure the temperature right at the tip. They'll measure the temperature a little ways away from the tip. But they have sort of advanced algorithms internally, like Kalman filter type things, that measure that proxy temperature, and from that and the change in that signal extrapolate what's happening at the tip. So those sorts of irons, if you take the tip of your iron and you touch it to, like, the edge of a giant inductor with a giant glob of solder on it, the iron detects that and it says, okay, we are sucking a huge amount of heat out of this tip, so let's dump energy into it to keep it at the proper temperature. And the experience you get is much different. It's very nice because pretty much as soon as you touch the tip of the iron to anything, that thing melts. And that's not something that's simple to do. That's something that requires a lot of power and a lot of control. And so, but we can still do it with these, and I'm going to show you that today. And I'm going to go through just kind of start to finish again doing a board. I'm also going to show you how to populate the board piece by piece, test it along the way. We're going to verify the operation of each component of the board as we go along. I wanted to talk a little bit about the design, though, the circuit design, because there's a couple changes that I wanted to make. So the first thing I wanted to do was, if we zoom in on our, this is our sort of pulse generator circuit that generated the signal for the sharp sensor. What this does right now is it generates a 50% duty cycle pulse wave. And so what that means is for half the wave, the signal is on, which turns on this sharp sensor, right? This T LED, which basically gates the LED inside the sharp sensor. And this does not have to be on for half the cycle. In fact, the sharp specification was like 300 microseconds or something. This had to be turned on. We're leaving it on for like half a second. And so what we're doing is we're letting the LED turn on for much longer than it will operate. And it's turning on and basically just draining the power. So we're running this LED, and all we're doing is just fully discharging the capacitor, fully draining power, straining our boost converter. We don't necessarily want it to, it doesn't have to, it'll still function that way, but it's wasteful. We'd rather have a smaller duty cycle. So what I'd like to do here is and I can probably just, I don't know why it's not working for me today. Alright. Oh, you know what? This feels like what happens. Yeah, when I'm not connected. Oops. Okay, now we should be, we should be in business. Yeah. Okay, that was weird. It really locks you out when you don't, when you can't prove you've paid. So what we really like to be able to do is something like this. Let me. So first of all, this is, I changed this one in the design to 100K. So if we do something like this, okay, now what's happening here? Well, now when this output goes high, when it gets that pulse high, which triggers the sharp sensor, that high signal, which is going to charge up this capacitor until this voltage gets higher than this reference voltage here, now it's going to charge it much faster. So when it goes high, that high signal is only going to see a 10K resistance to charge up this capacitor. The low signal is going to see a 100K resistance. We could probably actually even push this even further because it really only needs a tiny little pulse. But what this is going to do is it's hopefully going to let us shorten that time window for the pulse, which is going to mean we're burning less power when we're doing this measurement. And we hopefully will not fully discharge the capacitor, although I'm not quite sure about that. But this is a technique that we can use to do that, to sort of change the lopsidedness of the charge and discharge. And I haven't tested this. I haven't made sure this works. All I did here in changing the circuit was just draw this to show you what I'm going to do. I'm going to kind of retrofit this on my board. So if I look at R6 was the resistor here. Yeah, so I am probably going to put the 10K resistor here, and then on top of these two, put the diode across the top. So you might see that in the video. If you see that, that's what I'm doing. I'm kind of adding this extra little circuit. I'm not sure it's going to work. We'll see. We'll see if it works out. So I'm just going to jump after this into soldering, showing you the soldering, and fingers crossed. So we got something a little different today. Some of you complained about not being able to see things in the last soldering video, so I set up the microscope camera, which is recording right now. Hopefully it's recording. It's kind of a separate recording thing. So start to finish, we're going to be doing, I guess you're going to hear in the background every time I get an email here, but we're going to be hearing, we're going to be doing start to finish with the cheapo soldering iron. And again, there's been no, the only other things I'm going to use are some tip tinner, some solder wick, and I'm going to use flux and solder paste. And these are big versions of this stuff, but you can get the smaller versions from pretty much anywhere. So, and I include, for people in my class, I include the little tiny little baggies of these things. But to be fair, I'm going to just dispense these with just a needle. So I'm going to use a needle to do my dispensing. Which is maybe not good considering how big these things are. Well, I guess it is what it is. I think I'm going to be kind of messy by the time I'm done here. Actually, I'm feeling like I should get gloves on. So safety goggles, gloves, both critical for this sort of a thing. I don't know if we have gloves. Be right back. Okay, I got gloves. I also got a better option for the solder paste and flux, so I'm going to use the exact kit that I provided people. All right, so I'm going to start, I'm going to open up the iron kit, see how this thing goes. Got some electrical tape. They threw a bunch of goodies in here, some heat shrink tubing, the iron, the tiniest sponge I've ever seen in my life, some tips. Actually, they got a lot of stuff in here. Wow, this is only like $8, and there's a lot of... I'm impressed. They even have a solder sucker. So if you have too much solder, one thing you can do is you can use these solder suckers, get the solder melty, and then put this little vacuum tip up against it and go pow, and it sucks the solder off. So that's a good way to remove a lot of solder if you don't want to waste some solder braid. No, that's neat. It's all included in there. I guess I didn't pay close enough attention to that. Let me have this little tool too. It looks like a little wire stripper, like a little. Yeah, that's nifty. Okay, you know, so for $9, you actually get a lot. I'm kind of impressed so far. Came with these tweezers. They are pretty good. So if you look at, I'm going to put this under the microscope here. You see the tips of those tweezers? Come together pretty good. I think that's going to work. Okay, I'm going to try to see how this is set up. So looks like, I don't know how this works. I hate to read instructions, but I'm not quite sure how the thing's supposed to. Looks like it bends up. I gotta find a picture of this thing. Alright, I don't know. Alright, step one. Go online, figure out what to do with this stupid thing. Okay, after consulting the internet, it looks like this thing bends up completely. Like that. And then the sponge is wetted and just put kind of behind here, it looks like. So I might move the iron off to the side. I'll probably get this paper a little wet. Let me go wet the sponge. Okay, so now we have a wet sponge, soldering iron, has a tip already installed. One thing to note with these types of cheapo soldering irons is, you know, you want to tighten down this little sleeve so that the tip is right now is wobbly. This sleeve that goes all the way around it, you want to tighten it down kind of tight on the tip. The problem is sometimes when these things heat up, they kind of get loose again. So sometimes you have to kind of while they're hot. If it's feeling loose while it's hot and it was tight while it was cold, sometimes, you know, get like a pair of pliers or something and tighten it down a little bit while it's kind of while it's heated up to temperature. So yeah, again, this is me doing this for the first time, just kind of going from scratch. So let's plug it in. Okay. So there seems to be a little dial on here that can adjust the temperature. I'm setting it to like 350. We'll just see where that goes with it set to 350. Let's give this thing some time to warm up. While it's warming up, I'm going to open up the tip tinner. One of the biggest problems I've had with these cheap soldering irons, and I haven't used ones that are this cheap in the past, but sometimes these tips are kind of made out of a kind of Chinesium that sort of, it has a tendency to, when you're using lead-free solder, the lead-free solder will dissolve the metal in the tip. So the biggest challenge I've had is over time, the tips of these sometimes start to degrade, start to erode. It looks like this comes with a finer tip also. So I'm going to try to get away with the tip that's on there, but it looks like if we have to, we can upgrade to like this finer tip, and we might end up doing that. I'll show you how to do that if we do. So this is feeling kind of warm. I mean, I'm getting my sense of smell is telling me it's starting to get warm. Still not much wiggle on there. I'm going to try it in the tip tinner. So it does melt the tip tinner. So tinned. That tip tinner is just, the sponge isn't grabbing this solder very well. This is a key time to make sure as you're flicking solder around, it's very important to make sure you have goggles on too. So. I also bought this jumbo pack of safety glasses, so if you're in my class and you need safety glasses, come and get them. Well, call first. Okay. Well, let's just go ahead and get started. It's kind of changing color. The tip's kind of changing color. I might hit it with the tinner again. Take it down a little bit further. Get that coated with tip tinner. So. This might actually be too hot right now. It's kind of feeling a little warm. If I can get away with it, I might turn it down. So I'm just setting the dial now to, I guess, 350. It's a little hard to tell. We'll try it at 350, see how that goes. I'm going to start by soldering on the USB connector as I did in the other video. Now I'm going to be mostly doing this using solder paste. So I'm going to try to use this with solder paste as much as possible. You don't always have to use flux when you have solder paste because it has that flux built in. But after you get it melty once, it's really a good idea to switch to use extra flux. So if you ever come back to redo something with these, at the very least do flux then. So as you can see on the microscope view, I am just smearing some of this on here for now. It's being a pain. Could be this stuff was left out a little bit too long. Oh well, we deal with it. That's a mess. I can feel this video is going to go badly already. I can feel it. So we're still good on the camera here. So I'm going to come in with the iron now. Cheapo iron, test 1. You know what? I had to put some tissue paper over the microscope light because it was causing issues, and now it's making it tough to see. Okay. Alright, it's going okay so far. There's probably a little light on the flux here. Or a little light on the solder paste. But I think it's getting the job done.
I'm going to come in here and just give it a little flick. I'm just trying to catch up these extra little balls in here. Don't want them kind of wandering around. Looks like I may have melted the plastic there. So don't do that. Trying to reach those little solder balls in there. Okay. Alright. Let's clean the tip. Get that melted plastic off the tip. So far I'm pretty happy with that. So I think we got a decent solder there. That top one maybe is questionable. We could put more on there. It might not hurt to put more on there. Yeah, this iron is plenty hot enough right now. I might turn it down actually. This is, you know, it's a fine line between hot enough and so hot that it could damage your parts. I do not believe this is currently at 350. So I'm going to turn it down to about, let's see, 320 there on the dial or so. So I'll turn it down to there. Hopefully that works. So far I'm pretty happy though with this USB. I'm going to flip it. And we're going to do the back side here. I might zoom out a little bit if I can. Again, sorry, I think I'm going to be fiddling with this stupid diffuser I created here for a long time. Now I'm still going to use the flux. I'm still going to try to do this with just flux. And the iron, or not flux, sorry, with paste, solder paste and the iron. And now with these big through-hole ones, it does take a lot of solder with these, typically, but you really kind of want to look to, the solder will form sort of like a little meniscus when this thing is ready. So, alright, see how I kind of formed that little dome? It usually means it's fully wetted in there. This iron is still pretty hot. So I can still see the pin in this one, so it might need a little bit more. The main thing is I want to make sure it melts all the way down into the hole here. Yeah, this iron is still, I'm going to turn it down even more. I'm going to turn it down to like right at the 300. I'm going to add a little bit more paste here to these back ones. Okay, so looking inside this hole here, it doesn't fully cover it, but it's probably good enough. It got that meniscus, it got that kind of, you can see it get shiny, and oh, now it fully filled in. So it looks like we have a good mechanical connection there. So I'm feeling pretty good about this USB right now. Let's move on to those R1 and R2. Those are 5.1K resistors. Now for these, I like to, whenever I'm working with just an iron, I like to just wet one pad. And I like to start with one pad. I'm going to rotate this so I have a better angle with my tweezers. And then I always like to start by just getting some paste on one side of these pads. So let me show you how I do that. So I'm going to just put paste on this pad and this pad. And then I'm going to come in with the tweezers, grab the part, and I'm only going to do 1/2 for now. Now I want to be a little careful of these actually lay flat, but they kind of stick, right? If you get heat, it kind of sticks to the iron a little bit. Gravity doesn't mean much with these little parts. But once we get one side done, then what I'll do is I'll rotate it around. Just so I have a better angle on the iron. I will put a little bit of solder on the other side. If I can get some near the edge of the tip of this thing. I can already tell. I'm going to cut this video short. I'm not going to do the whole board. I'm just going to show you the start. And then come in here to the other side of this. And hit the other side with heat. And hit the other side with heat. And that looks pretty good. Now, one way to tell your iron is probably too hot is if you're putting heat on one side of the resistor and it passes over to the other side of the resistor, then that's going to tell you that there's probably too much heat pouring in. If it's melting both sides, it's way too hot, and you want to turn that down. So mine's currently at 300, and it seems to be going just great. So I think those resistors are on there okay. Now let's do the R3, the resistor for that. That's a 1K. And again, my board is already flipped in this orientation, so I might as well just do this side of it first. But you know, with me, I always like to do one side, get the part secured, then come back in and do the other side. You know, I'm just going to put a dot on the LED too. And then we're going to take that resistor. And if the resistor is flat, when the tweezers pick it up, as long as the tweezers are in the same orientation, it'll be flat when you put it back down. Good. I don't believe I have it. I think I have to grab a diode. So. Blue LEDs here. This is good. This will let me give you a chance to show you the LED markings under the microscope. So I'm going to zoom in on this thing. Sorry, every time I zoom in on this microscope, I got to change the focus here. Okay, so this is our LED, and there's a couple things. You can see a little, oops, you can see a little dot on that top right side there. That is typically a cathode marking from the top. The reason they sometimes have this from the top is it lets robots look at it. So when you have a pick-and-place robot actually doing this assembly, usually when it grabs the part, it can look at the part from the bottom and it can kind of see the marking. You know, it usually grabs the part with a vacuum needle, brings it over to a camera, and the camera can view it from the top and bottom, and it orients it and rotates it however it needs. So it's usually okay with markings on either side. But having a dot on top like that can sort of expand the types of test equipment you can use to verify this thing's assembled right. Looking at the bottom, let me flick this off to the side here. My tweezer's starting to get sticky. So looking at the bottom, you can see, let me rotate this. Oh man, sticky tweezers, nothing's worse than that. So if you look at, usually the way these work is, see the, if you look in white, you can see the letter C in that white of the chip. See how it kind of makes a C like that? That's the that's usually the way I think about it as the cathode label, is the part that makes a little white C. What's confusing is there's also a vertical line here. So you might think, well, the vertical line, that's the cathode side. Well, no, not normally. To make things even more confusing, Some manufacturers do make that vertical line. They do make that line the cathode side. So it's tough. But normally 90% of the time, this white with the C you can think of as the cathode side. Also, you can kind of pretend this is a triangle. Right? So if you pretend this is a triangle, that's another way to think about it. I'm going to rotate this around. So the dot and the C are two pieces of evidence that that's the cathode side. So signs point to yes. We're going to come in here with our iron, put this in place, and we've got to kind of reach over this here. And melt that in place. Maybe let go of it with the tweezers, give it a little more melt to flatten out. Okay. Now I'm going to rotate this part way. I got to get my iron in here. So I'm going to rotate this just part way. Come in here with some more paste. Oh, that's a mess. Come in on this side with some more paste. Also a mess, but you know what? I think it's going to be okay. So come in here with the paste, and boom. It's got a big goober on top of it, but it's all right. That'll wash off. You know, you want to be careful with that plastic lens. That plastic lens of the LED can melt, so you don't want to touch the top of LEDs. Now let's push the limits of how far we can clean this up with heat. See, I kind of got both sides melty there for a second. It kind of shifted, so watch out for that. Yeah, I'd say this iron is still kind of hot. I might bump it down to 275. See how that goes. Okay. That's good for that. Now let's do R4 was the current resistor, which I had in my design 10K, I believe. It is a 10K looking at it, so I need that here. So I have a special baggie of parts from when I did my assembly earlier, and so yours, I grabbed a couple little ones that are there, but I also have big strips that I had used for mine. So the nice thing about soldering as we go is there's no really wet solder on here, so we don't have to worry about a part flying off. Everything kind of gets secured down as we're going along. So I don't, you know, it's kind of a more tedious process with an iron, but one of the things I like about it is, you know, we can play games like this. So let's do, again, one side, let's get that capacitor too. That's a 1 microfarad capacitor. And we'll come in here. Now I did look at, I told you about these resistors and their numbering convention, and I did look it up afterwards. It's kind of embarrassing. I didn't really know what this code was. So the number on here, first of all, it's not hexadecimal. I think I said that in the last video that it's hexadecimal. It's not. It's a number that lists which position in the 1% resistor table it's at. So this is a 10K resistor, so that's a 10 is 0, 1. It's in the first position on the table. I'm going to rotate this board. And then the letter that follows tells you what magnitude table you're working at. So this one is an O1C. Oh, see what just happened? All right, that's called stonehenging. So stonehenging is when what happened is this part wanted this resistor, it's kind of hard, it's kind of a little dim here, but this resistor just wanted to, it wanted to fully wet its pads here. Yeah, so it wanted to fully wet its pads, and so it kind of went vertical like that. See how it, you know, upright like that. That'll happen when you only have solder on one side. So that's a price that we pay for soldering in this manner. It's easy enough to just kind of bump it back down. But I wanted to point that out. That did happen to several students who did this in lab. So it's not the end of the world. We just give it a gentle little tap, push it back down, and then it usually stays down once it's down. But yeah, so that O1C means it's in the first position. It's in position O1 on the table, which the number 1 is. And then it's the C is the magnitude table. So this must be that, the C must refer to the starting at 10,000 table here. Oh, I also had that capacitor that I was going to do here. Well, I don't see my 1 microfarad, so I'm just going to put a 10 microfarad in here. So it's not the end of the world. What did I say in the first one? Step 1 is be prepared. Have all your stuff ready to go. And I failed step 1 here. That's on there. That might be a little light on solder. I think my temperature is about right. I'm actually going to bump it up just a smidge. So I'm kind of feeling this out, getting the temperature dialed in on this iron. But right now, looking at the sticker, mine's set at about what I'd say is about 285 degrees. Is about where mine looks to be set. Come in here with these. The other side. And actually, I'm going to put something more on this side too, because I'm a little worried about. I'm not worried; it's fine, but it was a little light. It was a little tough to get the heat on that one. Okay, that one looks good. All right, let's do an IC. The other thing I'm going to do as I do this video is I'm going to show you how to test as we go along. So we're building this piece by piece. So we're doing the battery charge regulator first. Then we're going to test it, and then we're going to go from there. So once again, I'm going to do 1 pin. Start with 1 pin, get the thing secured, then go from there. So starting with 1 pin, I'm going to rotate this. I like to rotate my board as needed to make the soldering convenient. Put the chip down. Kind of let go of it to make sure it's flat. It can be very hard to see sometimes whether or not it's whether or not it's actually flat. You can also give it a little tap from the top while applying heat, and that's good. So with pin 1, we want to get everything oriented and stuff with pin 1. Because if we get more than 1 pin soldered, when we're just working with an iron, it's much more difficult to fix it. So now I'm going to come in here, give it a little smear of solder. Now this is, this is not great. This is not an ideal way to dispense solder, but I'm trying to be realistic here and do the same. I kind of like to do the adjacent pins. I'm going to start with pin on the other side just to get everything secure, and then look at that. Still see that? Yeah. Okay. I also want to say, as a caveat here, I do not have any kind of like soldering certification. So there are many soldering certifications for people. So I am what you would call an amateur solderer. I've done, you know, a lot of it, but I've never been trained to do it. So you are getting advice from somebody who is not a pro. Their professional soldering certifications usually relate to the ability for people to manually solder, you know, 144 pin type devices safely to where it doesn't destroy the device. Everything we're working on here is not that sensitive. These irons we're using are probably not what you'd want to use if you're using sensitive parts. But and I'm not certified, so just a heads up. But I don't have to be. Okay, let's test this right now. Let's test this. And you know, I said all I was going to use was, you know, the stuff I pointed out. I'm also going to use a little alcohol. So it's probably going to work fine as is, but I'm going to use alcohol and a little brush just to get this cleaned off. If you're doing this at home, you know, this is just isopropyl alcohol and a little chip brush. You should be able to get at any store, pretty much anywhere. Maybe a little Kim wipe. If we have Kim wipes. Nope. That's fine. We'll do it just like you're doing at home. We have a Q-tip, which is definitely not lint-free. It leaves little barbs of stuff everywhere. The reason we do lint-free is because the little fibers in things that aren't lint-free can really be a pain. So the little cellulose fibers in things like Q-tips can really cause issues for us later on. That's why we kind of like the lint-free wipes. Okay, so I'm going to test this. I'm going to grab a USB cable. I might pause these videos, and then as soon as I get that, we'll come back and test. First of all, tap, 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 tap. Okay, we're back. Ready to test. We have our board and USB cable. So let's plug it in. Uh-oh. Nothing. That could be okay. So one thing with these charge regulators is it's not always necessarily the case that, oh, the cable must have been loose. When there's no battery connected though, sometimes it's a little weird what these things do. So now it looks like it's okay. What I'm going to do is I'm going to get a multimeter and measure. But again, without a battery here, this doesn't necessarily mean that much. So even, you know, if the light doesn't turn on, the light does turn on. Both of those not necessarily meaningful. So we can measure the voltage, but probably what's happening is this thing is starting to charge, and then it says, oh, well, there's nothing here. So then it turns off. So we could get, oh, 4.4. Yeah, that's a high charge it's doing. That's a really, and again, that could be just because there's no battery there. If we want a better way to test this, let's actually add a battery. I don't like to add a battery and permanently, because fiddling with a circuit with a battery soldered to it, it can be very risky. So let's de-energize this. I'm going to show you how to do the through-hole part. So I'm going to put a male header on this side of the battery connector, and then later on we'll do the female header. But soldering this male header, right? The problem with these is we have to hold them in place on the top while soldering them on the bottom. And the key to this that I found is have your finger on one pin and solder the other pin. So apply pressure with your finger on one pin and then solder the other. If you solder the pin your finger's touching, you're going to burn your finger like almost immediately. It's really pretty, it's pretty bad. It immediately conducts heat very well. So we're going to kind of align this with our hand. I'm just going to, again, I'm trying to do this all with solder paste. We're going to align this with our hand and then apply heat to the pin we're not touching. And so for my hand, it stays nice and cool. Right, I'm not feeling this at all. And it looks like it's maybe a little misaligned, so we're going to put heat again and sort of shift it a little and get it nice and aligned. And that looks pretty good. That's looking pretty good. So now we're just going to come in here and we're going to hit the other side with, we're going to get the other side nice and melty here. Okay, just clean up some of this extra these little solder balls here. Okay, looks pretty good. Now for the battery is kind of a another interesting story. So there's a lot of bad things that can happen with batteries. So in making this video, I'm going to pull a battery out of a kit for somebody. So somebody's going to get a pre-soldered battery here. So the key thing with batteries is we don't want to cut across the battery. We don't want to snip all the way across this thing. And because if we snip across it, as soon as we cut across both of those terminals, it's going to short the terminals. And these LiPo batteries are incredible. They will weld your scissors you're cutting with. So what I always like to do is I always like to separate them and cut one. So I cut one. I'm going to cut the ground. It doesn't matter which side you cut, but I'm going to cut the ground one. And I'm going to leave the other one connected, right? So right now, there's no way for these to short on each other. And then I'm going to do everything I need to on this side, and then I'm going to go back to the other side. So we have, do we have wire? I guess it came with that little wire stripper widget thing. Let's try to use that. We're learning as we go here. So let's put this thing through here and then cut down. Oh, no, maybe this widget might not work. Let's see. This might be for big wire. Yeah, it worked okay. I kind of had to snip it a few times, but so now let's flux this. So let's just punch it in the flux. Just dip that end in the flux there, and then let's also. Oh, I should have probably before I did that. So this, if this kit came with heat shrink tubing, let's use it. So let's. The little stuff that I need is in the bottom here. So I'm just gonna make a mess. I'm just gonna dump it out here. Oh man, it comes with a lot. Man, I can't believe this kit was $9. I'm not affiliated. I'm not doing an affiliate link or anything like that. But wow, you get a lot of stuff for $9. Thank you, China. I'm assuming. Okay, so what I did is I cut off some heat shrink tubing and I slipped it over the end there. Now I'm going to solder, and actually that's probably a little too long actually. So let's snip it a little further. Slip this on there, and now I'm going to. This is tough if we're just trying to use paste for this, but we can still do it. So I'm going to take a big old glob of paste, put a big old glob of paste on one of the posts here, maybe both of the posts, and carefully holding this in place, I'm going to apply heat. Can you see that? I think you can. I'm going to apply heat. Melt it. Now it dripped molten solder paste on my paper, which is probably not good, but c'est la guerre. That's French. I am multilingual. I assume that's French. I don't actually know. I think my dad used to say when I was a kid, and I think it means "so goes the war" or something like that. I don't know. Okay, so now we have this side soldered, and we have some heat shrink tubing. If you just have an iron, one thing you can do is slide the tubing all the way to the end there, and then starting on the side. So if you shrink up this side of the tubing, it's gonna. If you start on this side and shrink it, it's gonna pull the tubing this way. So we always want to start by shrinking the side that's around where we need to isolate, where we need to insulate. So I'm just gonna kind of brush the heat shrink tubing with the iron. Sometimes you can kind of use the back of the iron here. So just kind of rotating it around, getting it all shrinky, giving it heat. You're not supposed to do it this way. You're supposed to use like a heat gun or something, but you know, we don't always have a heat gun. I don't got that fancy heat gun money here. So just touching it with the side of the iron, just gently kind of caressing it, shrinking it up. This is probably really, somebody's probably gonna like post a comment. That's killing you. You're producing chemicals that are, I don't know. This might have been the wrong size heat shrink tubing. It's not really shrinking very well. Oh well. So we're just getting it all shrinky. Well, it looks pretty good, actually. I'm very happy with that. That was a solid B+ effort. So now we've got that side all secured. Now let's cut the other side. So now we're going to snip the other side. And once again, we'll use our nifty little thing here. I kind of had to cut and then rotate and then cut and then rotate a few times. I kind of had to snip around it before pulling it off. And that looks good enough. So now once again, we're going to dip those leads in the flux. I probably should have put the other side in the flux too, but it's getting the paste. So, and we're going to get a dollop of paste on this thing. Move this wire into position. Like with everything else, you kind of need 3 hands to do this. Hit it with the iron carefully. Oops, I missed. And I dripped. That's why we wear gloves, people. Not that these gloves are meant to help against molten solder, but... Alright, try number 2. Oh, I didn't... Yeah. Before you solder, if you ever want heat shrink tubing on there, you better get it before you start. So let's slip that heat shrink tubing on. I'm going to get a little more. What I'm going to do is I'm probably just going to get this post melty first and get this thing melty first. So I'm going to get the post, give the post a nice melty. I dropped solder in the vat there. So I got them both melty. Now we'll connect them together. And I probably should have stripped more insulation off this thing actually. It's kind of, I think we're running into an issue of the insulation is, we'll get it. That get it? Yeah, it's not great. That's a C- effort. But it's soldered, it's connected, it's good enough. It's not a great solder joint, but all right. Now I slipped it over, starting on the side that needs to get tightened. Start shrinking that side up. Yeah, we're kind of burning it here. It's all right. Again, this is my C- one. I did a great job on the negative terminal, so this terminal, whatever. I've proved I can do it. Color coding everything helps. You don't have to because you can still see the wire, but it helps. Okay. All right. Now, so for testing the battery charge, now I can, now let's clean up the workspace a little bit here because I had dripped molten flux here. Okay, so for testing the battery charge, we're gonna make sure the battery is oriented correctly. We're gonna plug it in, so red side towards that positive label on there. Okay. Now we're gonna plug it back in. Okay, so now the charge light comes on, as it should. Now this is where we're going to use our test points. So I want to see, where are my test points? Where are my ground test points? So Oh, maybe I don't have them on this one. Oh, yeah, I do. Okay. So my ground test points are... Uh-oh. TP9 is ground. And then bat positive is... nowhere. Well, I didn't put a test point on my battery. Is that true? Where's TP2? Where's TP2? Oh yeah, TP2, VBAT. Okay. So take my meter and go to TP9 with the ground. So where the heck is TP9? Here we go. TP9 and then TP2. 3.906. So that's a somewhat discharged battery, but let's watch it and see if it goes up. Yeah, so we're charging. So we have a battery in here. We're successfully charging. We've tested this portion of our circuit. We're good to go. Okay. You always want to be careful when you connect leads to a board too. It's easy to short things, so you always want to be careful with that. So we know that's successful. We're going to de-energize our circuit. We are going to separate our battery. And we definitely don't want to have that battery in there while we're doing soldering. That's really dangerous. So set the battery. Actually, I'll put the battery. Well, yeah, I'll leave the battery here for now. Let's do the switch now. So now let's go to the switched power here. Bad preparation on my part. I gotta get out of the parts cabinet. Okay, transistor, hand switch. Let's go back to microscope view here. It's been a while since we've used our friend's microscope. So sorry about that glare on the microscope too. Oh, man, I've been trying to get rid of it and I just can't. So it is what it is. So we're gonna put on our transistor first. Little needle. Oh, that's frustrating. For this one, I'm not too worried. I'm just gonna get the whole thing. It ain't pretty. This thing does not want to come off here. I bet that'll work. That's about as bad of a job as you can do smearing solder paste, but I still think it's going to work. So now, because we put that battery terminal thing on here, we kind of have a mess here. So that's why we usually like to wait as long as we can to put that tall surface stuff on there. And I might even rotate the board here because that's how much I don't want to deal with this post. Set it in place. Get one pin soldered. Sometimes I give it a little pressure, just light pressure. Let it reflow, just to make sure it's down flat. And now I'm making everything worse. So again though, you have to fiddle around with it with one pin. It's a lot easier with only one pin solder. Now I'm going to come in here and get this other one. So get everything ready, get everything where you want it with only one soldered, because as soon as you get two soldered down, well, guess what? Now you got a problem. Okay, all that stuff, we can clean that up with alcohol later. Let's get the switch in there. Now these switches, students had issues. I forgot to tell them, you don't want to hit these switches with a heat gun. These switches melt. The plastic is, I probably went cheap and got them for almost nothing per part, but they don't handle heat very well, so you got to do these by hand. This thing looks gigantic. Another thing students noted is how in the videos everything looks kind of big, and in fact, and then they get to it in person and it's tiny. That is a problem, right? That is also when you're doing it in Altium, when you're doing the PCB design, it's easy to lose perspective of how small this stuff is. It's very tiny. Okay, switch is in place. I think it's time to clean this soldering tip a little bit. So just brush it on the wet sponge. Make sure the sponge is still wet. I'm actually very impressed with how well this iron is held up. This is a very functional so far. Okay, now we can verify that our switch is switching. So the measurement. So after switch bat is TP5. It was a TP5. It's got to be TP3. Yeah, it's got to be TP3. Okay. So we'll once again do a quick little verification measurement. I'm worried about this soldering iron. I kind of want to keep it off to the side here. Let's come back. Let's plug our battery back in, being very careful that it's oriented right. If it's oriented wrong, we're going to ruin everything. And then our ground should be TP9. And our switch bat should be TP3. We're being very careful here. So I'm getting 3.875 volts there. And then if I switch it, it drops to 0. Sort of. It'll get there eventually. Yeah, so it looks like we are switching correctly. Okay, so that's the off position, so that's good to know too. Carefully pull these off, right? It's easy to short things and damage stuff while doing testing. Okay. Boost converter. This, oh boy, look at that. We just stabbed our board here. Okay. Boost converter. Let's do this now. I'm going to start with the littlest one. I'm going to start with the little boost converter. So this is the one that's a little hard to see. So I don't know if you can see it in the video. I can see it on my screen. Yeah. So we see that bar on top. We had seen earlier, based on the data sheet, that bar is the side that has pin 1. Different parts are different. Some parts have a flat that indicates pin 1. Some have a dot. Some have a bar. Some have like a logo. That is now oriented correctly though. So now we can go in here and do our normal solder business. I just want to do one pin if I can. Let's try that. So coming in here, chip. We really want to make sure it's flat. So sometimes just like releasing it, then grabbing it again with the tweezers is a good way. But we don't want that thing to be floating on the board. Not great. Give it a little pressure from the top. Okay. That'll be good enough. Yeah, let's tweak it. Let's rotate it a little, just a little. That's equally bad. Well, whatever, it'll still work. So with me, you know, if I had gotten the pin on that side, I always like to then solder the other side. If it's oriented the way I want, if it looks like it's good, I'm going to do the other side of the chip. Okay, it's a lot of solder, but it looks like that's all just fine right there. So now, sometimes there's still enough solder on the iron. You know, I kind of want to give this a little dose of flux right now. I haven't been using the flux much. I've been just kind of relying on the flux that's in the solder paste. But let's give this a little dose of flux. And what I might be able to do is I might be able to use the solder that's already kind of on my iron to get the rest of this. So let's do this. Let's get this side a little cleaned up. And then, yeah, so it looked like we had enough solder still. So you're just kind of touching the tips, touching the pins, going back to the other ones. Wow, I am impressed with this soldering iron. I am once we got it dialed in, this thing is not bad. All right, so that's in its little flux sarcophagus. That's totally fine. Okay, now capacitors. Let's put our 10 microfarads in here. See, now one downside about using flux is now we got a bunch of flux on here, which tends to kind of interfere with, you know, if you put flux while it's in its flux paste form, flux does not do good things to solder paste. It tends to just kind of diffuse it out. It's still going to be okay, and I'll show you, but it tends, you'll see it kind of makes a mess. Oh, actually, I take it back. I'm fake news. Wow, it's hard to get down to that guy, though. Okay, we finally got it on the pad. You can kind of see when it actually hit, it kind of just wicked down. So you want to look for that. You want to really make sure you get heat. You want to make sure. Usually this is caused by the pad not getting hot enough. So you pull the part off, get some on the pad, get the pad heated up, and then you should be good to go. So it's harder on the other side, right? Now that these are on, it might be tough to get heat in there. Sometimes you just need a lot of flux. So sometimes you just need... So, going back to this, or sometimes you just need a lot. I keep saying flux when I mean solder paste, but let's just get a lot on there, make sure it'll go. Capacitors don't bridge as often as resistors. They kind of have a lot of bulk to them. One thing they do is they do melt both sides if you hold it too long, so you be careful about that. Okay. So clean it up a little. So if I do one side and get it melty, I like to wait until, you see how it goes from shiny to blah, shiny, blah. That's when it's hardened. So when it's hardened, Surface tension kind of creates a little ugly surface, and then we can go back and touch the other side, but we don't want to do them both at the same time, so otherwise our part will fly off. Let's do the other caps. I did for mine like to do these tantalum capacitors. So tantalum capacitors are polarized. They do have an orientation. So they have, typically they have a flat spot and they have a bar. So putting this in here. So you see that little bar, there's a bar on the board, there's a bar on the cap, there's also a flat spot. So there's a million ways to tell that these are what they need to be. I might just do both sides with paste right now. So why do I only melt one side then the other? Because if you melt both sides, it tends to float. I'll show you what I mean by that. So let's say this is already melted here on the surface. So let's make this side melty and let's make this side melty. Now the problem is I can't get this part flat on the surface, right? Even if I melt one side, okay, nope, still no. There we go. Okay, so that side's melted, but now my chip is kind of, I'll show you what I mean. My chip is kind of at an angle here. See, it's kind of floating there. It's kind of floating up on the board. It's kind of at a weird angle. Better. Yeah, there's not a good way to show this, but it's kind of floating up there, and so we don't want that. We want it to be flat, and so it's easy to get it flat if we don't have the solder already melted in a big ball on the surface like that. So how can we fix it if we have an issue like this? If we have an issue like this and we can't kind of get it flat like that, one thing is we can just not care, but the other thing is we can pull this off, and then we can go to our braid, which I haven't used up until now. And then I'm just going to dip the braid in flux. And then we can try to get our focus a little bit better here. Then we can clean up the fluxes on the other pad. So let's get this all cleaned up. Now see, this is where this soldering iron strains a little bit in this case. So that was the first time I really saw a big difference between a good iron and these irons. Is it took a little longer for it to get enough heat to melt that, to get it melted through the braid. Now let's put it back here. And now let's get this side melty. So now it's on flat. So now it's on there, one side soldered, and it's flat. So then we just have to come back in here and we have to apply more paste. And then we get the other side. Okay. And then let's do the other one. And again, sometimes sometimes it's not easy to tell looking down vertical whether or not it's flat. So sometimes after I get one side pinned in position, I put a little pressure on the top, just a little. Let it melt again, and then just make sure it's pushed down flat. Make sure it's flat on the surface to make contact with the other side. Oh, it's that stupid header, that stupid... Okay, now this is looking pretty good. Okay, let's get that inductor in place. Now these inductors that I ended up using aren't quite right for this footprint. So these are actually a little bigger than the inductor specified in the footprint here. So that's the inductor. You see it doesn't quite, it's a little bigger than what's stated here. We have enough room that it's okay, but actually it's pretty close. But this is a little bit different than what it's supposed to be. So inductors can be a challenge. Inductors, just because there's just big chunks of metal, you don't always have a lot of room. So let's get some paste down here. Get it kind of centered. Make sure it's not shorting the pins of that U2 next to it. Keep the heat on there for a little bit longer than you think, because that inductor, it's really easy with inductors to think you got it soldered, but you don't. You got it just kind of sticky. All right, so now that was long enough that we're pretty sure we're wicked on there. Oh, it's still hot. See, that inductor holds heat, so that other pad was still hot when I put that paste on there. Let's hit it. And again, I like to give it a little extra time. Make sure it actually soaked in. Yeah, see, it kind of pulled it in there at the end. You really want to make sure it got good. It's hard to see. It's very hard to see, but probably too much flux is better than, or too much paste is better than not enough paste here. So I'm actually gonna, just to be sure, really glob it on here. So I mentioned to somebody that I do these videos, and that I kind of, they're really long, and I'm not trying to make these long. I just kind of want to be honest. I want to sort of show the entire process. And I mentioned, like, I kind of run out of things to talk about. And so I asked anonymously on the internet if there were questions to talk about while doing these. And people gave some suggestions. I mean, basically I just said, I'm a professor, I do these videos and there's dead air, and what do I talk about? And so people gave some suggestions of things that I could mention. So if we run out of time, if we run out of things to talk about, I have a couple options here. Okay, so that should be everything for the boost. So what I'm going to do is I'm going to clean this. Give it the old Q-tip. Again, should not be doing this with a Q-tip, but we are. So. Okay. A lot cleaner. Not much. Still doesn't look great, but it's good enough. So now let's look at our data sheet. What's our test point? Our test point after boost is TP1. So TP9 is ground, TP1 is boost. This should still be off. Plug in our battery. So get our trusty multimeter here. Hopefully our video is still going. Looks like our multimeter was never turned off. Way to go, John. Okay, so TP9. Where's TP1 before I get too far here? Where the heck is TP1? Oh, there it is, right next to TP9. Okay. So TP9 is here. TP1 is here. Being very careful not to short those terminals. And then turn it on. Look at that. Can you see that? 4.995. That's pretty much 5. So we are boosting. So that is, our battery was like 3.8. We are now getting 4.995. That's verification that our boost is working. Now here's one thing though, and then we turn it off, and what happens? There's nothing to draw. What happened is there's nothing to draw much power. So those capacitors were charged up. So the input and output capacitors were all charged up. So even after we cut power, now power is off. It still maintains that voltage for a while because it, you know, yeah. So as soon as the input and output capacitor, as soon as the input capacitor Okay, apologies. My camera died. My camera died while I was recording that. So you missed all the narration that I did. The video from the microscope should still be okay, so I'll just consider it a silent movie. Maybe I'll try to talk over it later on. But for now, it is what it is. So, we had tested everything. One thing I maybe didn't show was testing the boost. So let's just really quickly go back and test the boost to show you how to do that. So for testing the boost, we're going to go to, it's TP9 and TP1. So it's off right now, so it shows 0. If we turn it on, 4.995. And then this is interesting. When you turn it off, it goes. So before I had put the op amp in there, it would wait. It would like hold at 5 for a while, and then when you turn it off, so now it doesn't. So 4.995, so it is boosting correctly, and then off. So we probably should get the rest of that op amp wired up here right now. So I got it's plugged in now to the wall, so we should be good now. But I'm not going to go too much further. One of the things I said is I'm just going to kind of try to get this op amp circuit done, and then we'll call that good there. So we're going to start populating some of these. We're going to start with the 10Ks. So that's R7 and R9. Okay. And we have a 100K, which I pulled here. So that would be R6 is going to be. Sometimes these tape reels are a real pain. Okay. That's 100K. So that was R6. Someone's kind of fighting me a little bit. Whenever they do that, I like to put pressure on the top. Make sure they're flat. That's good enough. Let's come in here and get the back sides of these. What's that R8? Where is that? Oh, that's the 20K. That's right. Now, one thing that happens a lot, and I'm going to show you how to do this really quick, is sometimes, what if this was wrong? What if we found out, oh shoot, R7 is not right. That is the wrong one. How do I get this thing off? Oh my gosh. Well, so not to fear. So normally it's hot air, right? And if it's not hot air, normally you have one of these. These are little tweezer irons. I don't know if you see that. So this would be one way to do it, is you sort of get these soldering irons that are two irons making a tweezer. But if you, and that's because normally I use the Metcal MFR 2200 is usually what I have at this station. You might not have, you know, $1,000 soldering iron. So you're stuck, you got your $9 one. So what do you do with this? Well, I'm going to show a couple options of things you can do, things you can try. So one is, sometimes if you kind of just, if you know you're going to get rid of the part, you can just apply heat and let it go long enough to melt the other side. Looks like that's not happening here. So sometimes you can quickly move it like that. You see that? So I had one side heated and I left it on there for a while so it stayed hot. And then I went to the other side and melted it and pushed it. Okay, so that's one option. Let's put this back here. We're starting to get kind of scaly. It's starting to look a little gnarly here. Okay, so I'm going to clean this up and we're going to do this again. So another thing you can do sometimes is go big. So sometimes people say, oh, it's soldered on, it's a mistake, I want to get it off. And their immediate reaction is to remove as much solder as they can. But sometimes it's actually beneficial to have more solder. So sometimes if you want to get a part off, you know, some students will go directly to solder braid and they'll try to suck solder off and they'll do what they can for that. And sometimes that doesn't always work, right? Like, you know, sometimes if you just try to solder braid this off, the solder braid will suck most of it off, but it's not going to suck it completely dry. It's not going to like have no solder left. So sometimes what you want to do is go the other way. And you want to say, all right, you want to stick on there? I'm going to let you stick on there. But you better really want to be there. So let's really glob this solder on. And now, with it really, we can have so much solder on there that we're actually able to, all right, so we have so much solder here, we're kind of forming these big giant mounds of solder on each side of our resistor. We're actually able to get the iron in and apply heat to both sides. So we can apply heat to both sides simultaneously, flick that thing off, and now we're done. And this resistor's done for me, right? So that's the other option, is to go big. So go with extra solder. And then after we get that extra solder on there, here's what we can do. We should come in here with some flux. Come in with our braid, being very gentle. Again, remember, we never want to tug with the solder braid. So we always want, especially when using these cheapo irons, you want to make sure that solder braid stays. You want to make sure it stays hot, and if it cools, to heat it up before trying to pull stuff off again. So now we're just going to wait till it's hot, wait till we see stuff get melty, and then we're just going to kind of sweep. You see, we're just kind of sweeping, wiping everything off. Beautiful. It's like it was never there. Like it never happened. All better. So now we can come in here with a new, whatever R7 was, 10, was it 10K? Yeah, 10K. Come in here with a new 10K. Do the same process we just did. I think there's enough stuff there that I can just do the other side with what's already there. Yep. Just gotta clean it up with the iron a little bit here. Boom. Okay. Now, what was that R8? That was the 20. That was 20K. 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 There's that thing. Here we go. Big goober on the end of that. My hand's getting dangerously close to this iron. I'm trying to kind of keep everything in video here, but hopefully you have more space than me. Don't be as reckless as me when you're doing yours. Okay. Okay, and then C7. That's that. Oh, that 10 micro. Yeah. The capacitors I'm having trouble with. You really want to make sure the pad is wet, the pad is soldered, and the capacitor is. So this one in particular is giving me troubles. I rotate it, and again, I just rotate it because I'm right-handed, and so I want the action side to be the side where my right hand is. Okay, everything looks good. Okay. Let's do the other side of this, the other op-amp circuit here. So R10 is 1 mega, and then the capacitors, which don't necessarily have to be. R10 is 1 mega. I got my mega. And C10 I think was, yeah, that was the decoupling cap for the op-amp. We don't have to populate that. And we only have to populate one of these capacitors. Remember, we gave ourselves an extra capacitor footprint if we wanted to, so we don't have to do all of these. We don't have to put a decoupling one on this op-amp because it's not really high speed. Now look at this. Look at this part number. You see the part on there? It says 01E. This is a 1 mega. So it's a 1 mega ohm resistor. So the 01 again is specifying it's the first value in the chart, and it is the E must be the you know the mega chart, you know, the chart of mega ohm values. And so then we're going to do another 10 microfarad here. we always want to make sure we get, see, now on this side I did one side and then I did one side of one and one side of the other before doing the other side. So we always want to come through and make sure we got both sides. It's a pretty common mistake when using irons, is to not, I'm worried, I don't think that actually just did what it was supposed to do. So I see, I never saw this wet the pad. See that? It's not actually wetting the pad. There's not enough solder in here. So I might be able to get some more, but it's really something to watch out for with these capacitors. Capacitors are much taller, so they have kind of their end kind of sticks out. So I'll get a little extra here. I'll make sure we actually get contact. It's still not going. There we go. Finally, man, these capacitors, they are tough. Okay, that's all we need there. Let's do the diode. The diode was important, so that's the through hole part. The hole part's easy. So I like to bend the leads ahead of time. Pop this through. So make sure that we got our diode pushed through with the leads coming through the other end. We're going to keep it tight. We're always going to tug on the lead that we're not soldering. So we're going to tug on the lead that we're not soldering here. Maybe I can actually get this in focus on the... So let's see if we can solder that on camera. These are through holes. They need a lot of solder, so I'm going to give them a lot of solder. That looks good. Now again, we want to make sure it's what we want. We want to make sure it looks like what we want before we move on and solder the other side. This is the other side. Okay. Now snippy snippy. Looks pretty good. All right, let's test it. Let's give it a clean. One thing with alcohol rinse, with the scrub, is a lot of times you want to scrub it and then afterwards put a lot more on. Just let it drip off. Because sometimes what students do is they'll clean stuff with the alcohol, but then they just let it sit there and dry again. So they don't ever actually get it off. So it's kind of a mess, and it just kind of leaves the film all over their board. So I strongly recommend, using extra, letting it run off to get clean. Okay. All right, so we're going to test this circuit as is. So to test this circuit, let's see, what's the output of this TP4? So we're going to start with looking at TP4. This can be hard to do with just a multimeter. So with just a multimeter, to TP4. Let's get our battery in here. So again, our ground is TP9. And then TP4 is that signal. Okay. Now let's just see what happens. So when we turn this on, looks like we're switching. I feel like we've successfully achieved switching. You know, one thing you can do here too is you can measure the AC voltage, which is a little too slow to get it accurate right now. Let's go to hertz. We can measure it with this. Yeah, again, I think this is too slow. We can kind of see the pulsing that it's doing. So we can see the pulsing that it's doing. Boom, 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 boom. This is just a little bit too slow for this meter. This meter just can't, it's not intending to measure hertz. So, but we can see it's like boom, boom, boom. It's fairly periodic. It looks like it's 50% duty cycle. If this were faster, we could probably actually measure the frequency of this, but we can't right now. So, so we got to know. We know it's clearly going from 5 to 0. We can see that just with the multimeter. Now I want to do my little trick where I was going to try to make this a little bit fancier. I was going to try to add this extra circuit here, and this is going to be a retrofit on here, so we got to be a little careful with this. But yeah. Okay. So let's do surgery and let's try to make this a little more one-sided here. So de-energized circuit. Let's turn it off too. So zooming in here, we have, so R6 connects to the output of the op amp right here. So R6 connects to the output of the op amp right here. And so this part is where R6 touches the capacitor. So R6 is in contact with the output capacitor, and that's the side where we want to connect R7. So we want to connect R7 there, which is not great because I didn't have that. I didn't intend it. I thought I'd be able to do it the other way. Well, we'll see what we can do. We will see what we can do. Yeah, we'll see what we can do. Okay, let's just start doing this. Let's stop talking, start doing. So first of all, I'm gonna get some flux in here. I'm feeling right now I'm gonna want a lot of flux in here. So we got to solder to this node the capacitor, or this new resistor. This has to be a 10K according to my thing, right? 1K, 10K. Yeah. So I'm going to start by just trying to use the solder that's already there. I'm not going to glob it on too much right now. Again, I want it soldered here, but I don't want it soldered to both sides. That's the problem. There's a couple ways we can play this. I can try to sneak it in the middle here. Try to do this. Let's see what I can make. Let's see what I can make happen here. Or maybe I want to do it like here. Nah. I want this edge to touch, but not the other. I think that's soldered on there. I think it's only that one side that's soldered. I do want to add a little extra. We're getting really dangerous here. This is not ideal. This is some advanced shenanigans we're doing here. So what did people ask me to talk about? Maybe that was in the part of the video that got destroyed. Could have been in the part of the video that I lost to the power dying. But I asked people on the internet that if I had dead air in a video, what are questions that would be good to talk about to students? And most of them were like, if you could go back and do it all again, what would you do different? That sort of stuff. Which is fine, but yeah, so most of them are kind of along the lines of like, what are stuff faculty know that students don't? And I don't have a lot of great answers for those kinds of questions. They are good, valid questions, but I just, you know, one thing I think is, a lot of students don't understand what faculty do. Like, I mean, they understand, of course, the teaching part, but the other stuff is something students often don't know. Students don't know about the kind of other obligations faculty have. You know, research sometimes, but even just the, you know, the sort of stuff that we do to kind of maintain university function. You know, serve on committees and meetings and stuff, and it really can be kind of a time sink for some of that stuff. I feel bad sometimes because sometimes we don't have as much time as we like to because we're serving on these million different committees for a million different things that don't always feel like they're that important, but I'm not going to complain too much on the internet. So what's other stuff that faculty know that students don't? Your course evaluations matter a lot, at least at this university. You know, we're required to read them all. We're required to sort of provide a response to some or most. So that sometimes is, you know, a big deal, right? If you leave a comment for us in our feedback, it sticks with us our entire time here at Western. And sometimes after, right? Sometimes if you're applying at another university, sometimes you're even, you know, they'll request to see your student course evals from your other university. So all those little comments you leave, they matter a lot. I know students sometimes think they just get thrown into a bucket, but they do not. So that's a big thing. A lot of questions, like professional questions, like if you could do it all over again, would you still do what you did? Those are also good questions that deserve good answers. I probably would. I don't think I'd change much about my trajectory. I got my undergrad in computer engineering, then I switched to electrical. They're pretty similar though, so it's not really much of a switch. I think that all was good. He sort of said if you did, you know, there was a lot of questions. If you did college again, what would you do differently? I don't know if I have anything there. I kind of, there's a lot of non-school stuff that kind of gets in the way of school stuff, I think. I probably maybe would have tried to avoid that. There was a lot of classes where I feel like I could have gotten a lot more out of them if I had, dedicated a little more attention to them. Some of them, I had some incredible teachers in college, and then, it's a weird age, you're dealing with weird stuff. I would sweat a lot, I would for some reason, up until I was 24, I would sweat. I'd change my shirt twice a day. I'd wear white shirts and stuff like that. It seemed very embarrassing at the time. It's probably embarrassing now, but I just don't care because I'm, past that point in my life. But it kind of stopped when I was 23 or something like that. I don't know what it was, but so there's a lot of times where I'd be just preoccupied in class with like these sweat puddles that are forming around my armpits. And this did not go well. But if you want an honest answer, I probably would care less about that kind of stuff and try to get more out of the classes that I take. Because none of that stuff eventually matters. Nobody really cares. So, it's hard to see that at the time. But I'll be honest, when I was that age, I couldn't see that. This is my hack job. This is my my hack job. I don't know if this is even okay. I'm gonna measure this to make sure it's the resistance I'm expecting. So let's put this here and let's. It can be hard to measure through it can be hard to measure through the little film that's left over from this no clean solder. Sometimes you got to kind of scratch through it a little bit. .48 kilo ohms. Yeah, so I think that is right. So let's see. Let's find out. All right, if this works, I'm gonna call. Oh shoot, class started 4 minutes ago. Shoot. All right. So we want to measure TP9 and TP4. Oh shoot. All right, measure voltage. Power on. Look at that. It's definitely shorter, at least. It's funny. It's faster. I don't know if it might be getting reverse leakage or something. Now I'm worried this might not work. Maybe I ruined it. I feel like that's good. I feel like it. Maybe it's just faster. Maybe the reverse leakage through this diode was so much that my 100K is now way less than 100K in both directions. Maybe my dioding. I don't know. Well, we'll call that hack job good and go from there. Thanks for watching, everybody. All right, I've decided I want to at least go through the extra step of doing a sharp sensor, getting that in place and ready to go. So let's put in the pieces to the sharp sensor here. We're going to start with the capacitor and the resistor powering the sensor. So I just got back from office hours for those of you who were in attendance. I'm going to re-wet this sponge to burn. Was this thing turned on? Yikes. Hopefully we still got battery left. Left the battery plugged in there. Okay. Let's put this capacitor on. These tantalum capacitors. This footprint for this tantalum capacitor is a little strange in that it doesn't have the bar on it, but it does have the little taper. So I'm just going to goop it on both sides here. So the taper, the little tapered edge of the capacitor, you see these tantalum caps have sort of one edge is, oh, this one's not. Well, the tapered side goes to the bar, so let's just say that. I tried to, okay. So the tapered side of the footprint is where the That's the positive side of the capacitor. And again, once your parts are secured, you feel free to move the board around as you need to rotate it to, you really want to make sure, don't fight the orientation of the iron. Don't have your iron dragging across parts on the surface. You really want to make sure it's oriented in a way that's convenient. It's easy for you to get in there. Okay. Now we got a 150 ohm resistor. I told people they can go with a bigger resistor, and you can. I'm going to stick with the 150 ohm for this one for now, because I tried to do this with that pulse with the. So I tried to shorten the pulse. So I'm hoping that we get the power savings. This thing being shortened here. So this 150 ohm resistor, the number on it is 18A. Looks like, so again, that means it is the 18th item in the table. And A is, A must be whatever table includes the 150 ohms. Or the hundreds of ohms, I guess. So. Okay, so get a sharp connector here. Apparently, I didn't have this thing stripped right. So as I said in the other video now, we have the tips of the sharp sensor. We're going to tin these. So I'm just going to stab them in the flux. Stab them in the gel flux. Spread them out. Actually, I'm doing this with paste, aren't I? So I'm trying to get this so you can see it on camera. You might as well just. We're gonna make a mess here. I can tell already. Yep. Boom. Okay. So tips tinned. Now we definitely want to clean that up. I left this big goober on here. Okay. Now don't mix these up. As you're soldering these, don't mix these up. So let's get our connector oriented right. Put one through. Now you actually can solder these from the top. You don't have to solder these from the back. So if you want it is possible if you're careful. It is possible to solder these from the top side. I'm still not going to do too many at a time. So let's just put, so now these are pushing into the board on the bottom here. So spread some, see that on the video? No, you can't really see that. So I just spread some paste. So these things are pushed into my solder mat. My iron was touching my capacitor there. That was bad practice. I should have kept that off there. You don't want to melt your capacitor. Okay. Next two maybe. Again, being very careful not to mix these up. Very careful not to get these out of order. And again, these leads are tinned, and the advantage of that is you don't have wires going all over the place. You don't have. Let's get these in frame again. So the advantage of that is you don't have the little wires shooting off to the side as you're trying to get them in the hole. That's why you want to pre-tin these stuff. Okay. Might be a little low, might be a little too little into that one. It's probably okay. It feels tight. I mean, I tug on it and it seems to be okay, so. Last one's here. I might just put a little extra on that one over there. Just cleaning it up. Okay. It's looking pretty good. All right, let's see. With this connected as is that all gonna work? Yeah, so we should be able to see the output of this now on TP5. So we should be able to see the output here on TP5. So I'm gonna go get a sharp sensor. There's a couple things I want to check to verify this. So we're going to first of all plug this in. There's a couple things I want to do though. So when the sharp sensor is powered, I want to look at my power rails. I want to make sure. That thing's kind of a pain to get in there, by the way. But when this thing is powered, I want to make sure that I'm still seeing 5 volts on my power rail. So that's the first thing I'm going to do. So I'm going to plug this in. Can't remember which way was on, which way was off. Oh, that's probably not good. So our power rails, to monitor the power, that was just TP9 and TP1. So we're going to measure here. 0, so let's power it on. And it looks like we're only seeing 4.3. Is that right? Uh-oh. That's not good. Oh, it could be my battery had died. That could partially be it, but I still should be seeing something better than that. Okay, let's check. What was the sharp sensor one? TP4, I think. Sharp sensor looks good. I think. I don't fully know. Well, let's check TP9. What was the output? TP6 should be the output directly from the sharp sensor. Not good. Well, so we're having boosting issues. So let's power it off and maybe we'll charge it up. And then we'll come back, and if that doesn't work, we'll figure something else out. So Trouble. All right, so what I did here is the board, I'm troubleshooting this a little bit. The board is turned on, or the switch is turned on, and what I did is I jumpered I took the battery off. I kept the negative terminal on, but the positive terminal is dangling off the edge, and I plugged a jumper wire into there. And so what I'm doing is I am now measuring the current through the battery while this is in operation. And look at that, 30 milliamps of current draw. So that's too much. And so probably I messed it up with my little diode circuit. I probably sped this thing up too much. So I'm going to put it back, and I'm going to go back and do, I'm going to kind of undo that and try to reduce this power consumption. It should also be noted, this is a way that we can measure the current draw too. So we can, if we want, we can go turn the circuit off, plug this in, and we can also measure the current flow to the battery this way. So we can see our charge current, which should be close to 100 milliamps. Yeah, we're getting, 86-ish, 87-ish milliamps of current while it's charging. But again, that current draw is too much. So there's a couple things we can do to fix it. So let's go do that couple of things to fix it. So one, I'm going to sort of go back to my original design. I'm going to desolder this. Let me start the scope recording here. So we should be recording on the scope now. We tried. We flew too close to the sun here. So I'm going to take all this apart. And that's good practice too. It's good to see how to desolder this stuff too. That off. This one, only one side should be soldered, so it should be able to kind of push off. Uh-oh. There we go. knocked it off. Now it's in the sponge. So we're going to get some resistors in our sponges. And then there's something else I'm going to do that I told people about, and that is I'm going to replace this resistor with a bigger one. So that's a 150 ohm resistor. I'm going to increase the size of that a little bit. Actually, let's leave it as is for now. Let's leave it as is for now, the 150, and let's just check the behavior of this guy. So once again, connecting only the negative terminal of the battery, putting our gnarly little jumper wire in the positive terminal. And then doing a current measurement. Looks like it gets pretty massive current draw when that thing first turns on here. Let's check our, all right, let's turn this off. Let's probe some other elements of our circuit. Ooh, 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 ooh. We had smoke. Why do we have smoke? Okay, so I don't know when the video cut out. My phone ran out of memory, so I had to clear up some space, which probably means I'm going a little too long here. All right, let's desolder this. So if we got cut off in the video, the issue we're facing is we're drawing too much current. It's burning our boost converter. So let's desolder. And again, like I said, sometimes to desolder, you want more solder instead of less. So that's the approach we're going with now. We're going to go with a more solder. Really get this resistor loaded up to where we can melt both sides and flick it right off. You see that? Right. More is less. Got that resistor pulled off. Now we're going to clean this up. So we're going to clean up the surface pads with a little braid. Okay. Now we're going to put a new resistor value on there. We're going to put a 500. So 499. Are we? Are we really though? Do I have a 500? Let's go with a. Let's go with a 400 for now. It'll work. So. Putting this 400 here. Okay. So what happens is the boost converter is choking. So the boost converter does not like to output that much current. I don't know why this thing was taking, well, I do know why it's taking 30 milliamps. That's basically just, that's basically 5 volts divided by 150 ohms. It's pretty much that. So that's the reason for that. So this will limit the current flowing into that. We also have to, because I believe we smoked our boost. So we got to get this boost off here now too. And once again, we're going to do a, this one's going to be tougher. Oops, what am I doing? This one's going to be a lot tougher because it's got a lot of pins. But you know what? If I expect you to do it, I can do it. Oh, jeez. So yeah, now we're going to bridge, and that's okay. I'm going to deliberately bridge. Get a lot of heat on here. Whoop, flick it off. See what I did? Lots of solder, lots of heat. Both sides. When you have a big ball of solder like that, it retains its heat very well. So that big ball of solder hangs on there, and it retains its heat. Now we could clean those pads up. I'm going to leave it as is. I think it's going to be fine as is like that. So, new boost converter. Ian's coming too, and we need to get him everything. Ian needs. That's right. Okay. So we could clean this off. I don't think we're going to need to. I think we're going to do it with what's there. Just recycling the solder that's already on there. And again, this is probably going to result in a chip that's floating a little bit. So this chip's probably going to be sort of lifted off the surface, and it's upside down right now. So, but it's going to be okay. So I'm going to show you how it's going to be okay. So put this in place here. And we still have a lot of flux, of sticky, goopy flux. That's okay. I'm ignoring a lot of my advice that I've given you right now. And sometimes you gotta... I got a little bridge there. This feels like a time for flux too. Flux. Definitely got a bridge. I don't want to have to do braid. I don't want to have to do braid. I'm going to have to do braid. The problem right now with using braid is, there we go, is these pads are off the surface. So it is very likely that braid would actually suck so much solder off that we couldn't make this work anymore. Okay. All right. Starting a little messier. So we replaced that. So let's get it cleaned. Okay. So yeah, I'm thinking a lot of the problem that a lot of your circuits had was that boost converter, because I just did do it what a lot of you did, and I don't know why when I first tried it, it didn't do that. But here's what it is. So I tried this with alcohol, and I told you not to do this with alcohol on your board, but try to clean this back up. Just clean up a little more of this stray flux here. Okay. Alright, let's give it a shot. When I power this thing up, I'm going to look for the smoke again. So I'm going to... I don't remember which way was off. Let's measure the output voltage. Again, that's not good. I'm going to disconnect the sharp sensor. Oh, shoot. Oh, I know what happened. I had it set to measure current. I was shorting the thing. What a mistake. So yeah, don't do what I did and have the meter set to measure current across your rails and short your boost converter. Whoo! Well, at least it's good to know that's what it was. Now notice this voltage is different. This is 4.984 volts. That's different. So let's find the output of that. Alright, that's the signal powering my sharp sensor. It looks pretty good. What's the signal coming from my sharp sensor? that's looking okay for a signal from, I think it's persisting. It's kind of just popping it up. Let's look for my signal on the other side of the capacitor. That should be TP5. Oh, wait, there's nothing plugged in. Okay, so once again, set to voltage, set to measure voltage. Turn it on. So it's wiggling. Yeah, it looks okay. 4.98, 4.99, a little bit of ripple, that's all right. Now we're going to measure the output from the sharp sensor. Let's go to TP5. So we're getting about 0.7 volts out of there from the sharp sensor. That's pretty good. Let's maybe make a little bit of smoke and see if we can get that to boost up just to verify. What can I burn? What can I burn? Hey Reza, you got something that can make smoke?
Yes, I do. I think. No, I don't. Yes, I do.
Like we're already getting a little higher. Burn. Oh yeah, can you burn in front of the sharp sensor? Okay, that's probably good. Okay, it's good. That's good. Now it's getting smoky in here. Without no, give it back. I need the smoke. Give me the smoke.
Oh, you do?
No, so I'll use the. It should still be kicking off a little. I don't know. Definitely got smoky in here. Once again, engineers should have 3 hands. Look at that. Okay. Yeah, clearly we're getting proper smoke response here. Okay, we want to be careful. We have 3 hands here. Okay, so I'm feeling good about that. Feeling good about that part of it. So okay, so we smoked it because I shorted it. That's my bad. So now everything's still looking good. We're getting a response from the sharp sensor. I'm going to call that good for now. The rest of this populating is much easier than what I just showed, so I'm going to call it good for now, and hope you enjoyed the video.